Hello and thank you for joining this video lecture. I hope you're doing well today and that you're ready for another interesting session. So in today's class, I plan on covering a very interesting Python library called Beautiful Soup. Our assignment this week will be using it, and it's a very popular HTML parsing library. And as usual, I'll do a PowerPoint presentation on Beautiful Soup, followed by some examples, as well as cover the weekly assignment. And also in today's class, we will start to learn about SQL, what it is, and how to use it to work with databases. Now the class today will only cover SQL concepts without any Python coding. And then next week, we will tie the two together. So I will do a very quick PowerPoint presentation on SQL, followed by some examples, and a demo of a little nifty database tool. Alright, so let's start with Beautiful Soup first. Now we already learned about fetching and reading web pages from the internet. For example, we can use the requests library in Python, and we can fetch files to read, we can upload data to servers, as well as delete them, among other things. But it's not always easy to deal with so much text and strings. I mean, it's hard to extract the data, especially if it was in an HTML format, with all the tags and the different elements. But luckily, there's also a very well-known library that can help us to work with HTML data. This library is called Beautiful Soup. And so Beautiful Soup is the go-to HTML parsing and web scraping library. It's lightweight, it's easy to use, and it's very powerful. It basically allows us to extract data from HTML documents in a very simple and efficient way. And where did this odd name come from? Well, back in the early to mid-2000s, most parsers could only parse well-formed XML and HTML documents. But what about the poorly formatted documents? Well, the poorly formed stuff was referred to as tag soup because web documents use tags in their code, and only a web browser could parse such documents. So Beautiful Soup started out as an HTML parser that would take this tag soup and make it beautiful, or at least workable. And so now we have this powerful HTML parser called Beautiful Soup. Alright, let's do some code examples now. Alright, so in this code example, we are basically going to go out to the internet, fetch some code from a web page, and we're going to be doing that using the requests library. And of course, we have to import it first. And once we fetch the data and get it back, we're going to be having a response object, and this response object is going to be basically the string of all the HTML. So instead of working with a string HTML, we want to create a Beautiful Soup object, which will be able to, or which will help us to work with the HTML tags in a more sufficient way. So anytime you want to use Beautiful Soup, you first have to import it, but of course before importing it, you have to install it first. So I'm going to go to my command line prompt. Let's expand that, and the command is pip install Beautiful Soup 4. Okay, we're in version 4 now. Hit enter. Okay, now you can already see from the output here that I do have it already installed. If you did not have it installed, it's going to start downloading it for you and then installing it for you. So let's go back to my code. So now that I have Beautiful Soup installed and now I'm importing it, now notice here that this import statement is a little bit different than the one up here. Basically, Beautiful Soup is a module in a bigger library called BS4. Okay, and now you can look at a Beautiful Soup as a class or as a module in a library, and instead of importing the entire huge package, I just want to work with Beautiful Soup because that's my focus for this example. So I'm going to import Beautiful Soup from this BS4 package. Alright, now within Beautiful Soup there's that class called Beautiful Soup. Now what this is going to do is it's going to create a soup object for us, but it does require a couple of things, a couple of arguments. So the first argument is, well, what text do you want to work with? And our text basically is going to be the response object, but the text attribute or the text property of my response object. So remember, I use the requests library to use the get method. I pass it a URL, and whatever gets back is going to be stored in a response object. Now just so you know what this example.com website is, let's go to example.com. So it's a very simple plain web page. Again, it has a header, it has some text, and it has a link. Okay, now to see the code behind this or the HTML behind it in any browser, you can basically right click and then do show page source. Now what this is going to do is it's going to give us all the HTML tags that actually is behind this page here. And you can see here that it says this domain is for use in illustrative examples and documents. You may use this domain in literature without prior coordination or asking for permission. Okay, so anytime you want to, work with data, just make sure that you have permission to also use that data. So the HTML behind this simple web page is basically, we have an HTML tag, we have a head tag, and then we have a title, we have some metadata, and we have some styling, and then we have the body. And the body basically is just that we have an h1 tag, which is the header, and then we have some text in the p tag, which is paragraph, and then the link is in an anchor tag or an a tag, and the actual link is an href, and here is the link to it, and then this is the text that is part of the anchor tag. Okay, so this is the HTML that's behind this web page, and every web page has HTML behind it. Okay, so this is what we're doing. We're using the request library, the get method. It's gonna fetch the entire text that's behind the example.com web page. It's going to store it in a response object. Now this response object has a text attribute, so we can work with the text. And for Beautiful Soup, the actual class called Beautiful Soup, we need to pass it what text we're going to be working with, and also what parser we're going to be working with. Now Beautiful Soup comes with I think 4 parsers. One is an HTML parser by default. You don't have to install it. It comes ready with Beautiful Soup. But there's also different XML parsers, and there's also an HTML5 parser as well. Now, you always need to go to the root for documentation. So this website, again, crummy.com, or if you just do a Google search on Beautiful Soup documentation, this will come up for you. Okay, now documentation are your friends. You need to learn how to look them up. You need to learn how to read them and how to use them, because there's no way to know everything, and so we always have to reference our documentation when we want to learn something, when we want to do something that we haven't done before. So for example, if you scroll down here and let's see, okay, this is installing Beautiful Soup. Okay, so here's the installing parser part, and here we have the different parsers and how to use them, and also the advantage and disadvantage. So there's the HTML.parser, and this comes installed by default. Then there's also the LXML, which is an HTML parser, but there's also LXML-XML, which is an XML parser. And then we also have HTML5 lib, and that's how you use it in your code. And again, just you could read about how to install them and the pros and cons of each. For our example, we're going to be using just the built-in HTML parser, and so again, you call the Beautiful Soup class. You need to pass it 2 arguments. The first one is what text they're going to be working with. Again, our text is whatever you got back from the request object, which is a response object. And how are we going to parse this text? We're going to parse it using the default HTML.parser option. Okay, now this is going to create for us a soup object, and I assign it a variable called soup. You can call anything you want, of course. This is just a variable name, so I called it soup. Now once we have a soup object, we can work now with everything that's in Beautiful Soup, like the different functions, the different attributes, the different properties. And again, that's the beauty of having Beautiful Soup at our disposal. Before Beautiful Soup, we had to do a lot of crazy things just to work with HTML and XML. So I'm very, very grateful that we have Beautiful Soup. Alright, so I have some print statements here, and basically I just want to show you the output of different things. So I want to show you what the actual soup object that we created here looks like. What does it have? Okay, so I just have a statement that says the entire soup object equals, and then there's a couple of line breaks, and then I'm going to output the actual soup object, and then I'm going to have a couple of line breaks as well between this print statement and the next print statement. Now within the soup object there are some functions that we can use. One of them is a function or a method called prettify. So I'm going to show you what the soup object, the raw soup object, what it looks like, and then I'm going to apply the prettify method to the soup object to show you how prettier, that's where they call it prettify, how prettier the HTML now looks like. Part of the soup object is that you have access to the different tags in your HTML. So if you remember when we were looking at the page source, these are all tags. You know, this is an HTML tag, a head tag, title tag, and so on. So instead of me creating code that says, you know, find, for example, using regex, I could find the title and get the text for it, but it's going to take a lot of lines of programming. But with Beautiful Soup, I can basically just, if I want to get, you know, this title tag and the text in it, I can basically just say, for my soup object, use the dot notation, and then call the title attribute or the title property. That's just how simple it is. Now this title property of the soup object is going to give you the entire title opening tag, including the text and then the closing title tag. Okay, that's what the soup.title will give us. But if you just want only the text portion, the value of the title tag, then you simply just call soup.title.text. Okay, so again, that's how simple it is. Just we have a soup object, we know that the soup object has HTML. Part of the HTML is a title tag, so here is the title tag. I can get the entire thing, or I can just get the text part of the title tag. Now, just like I did the title tag, I can also do the h1 tag and fetch its text. So if we go back to our HTML, actually it's there we go. So here's the h1 tag. It has a text attribute or a text value, and then has a closing h1 tag. Okay, so the soup.h1.text then should only give us whatever is between the h1 opening and closing tags. Another thing we can do is we can also call the a tags. And again, you can call any tag you want in the HTML. Once you have a soup object, then using the dot notation, you can call the a tag, you can call the p tag, you can call the div if you want, or the body, you know, any tag you have access to, just right from the soup object. So for example, if I want to get this link, well actually the link is an href, which is an attribute of the a tag, and a tag is an anchor. So here it is. If you want to get the a tag, then all you have to do is say print soup.a. Okay, now these three lines here do the same exact thing, but different ways. I could do soup.a, which is very, you know, straightforward and easy. You can also use a find method, which is part of the soup object, and you say, okay, find the a tags. Okay, that's one way to do it as well. So you can do it this way, or you can do it this way. All right. Now there is find. There is also find all, which we'll see in a moment. You can also get the text of the a tag of your soup object. Okay, and so basically here's my a tag, and here's the closing a tag. So the text is basically whatever text is between the opening and closing a tags, which is basically this text here. Okay, and if you want to get the href value, okay, which is an attribute of a tag. So href is an attribute of the a tag here. So how do we get that? Well, again, there are three different ways we can do that. We can say soup, which is a soup object, which has all the HTML, dot notation, and then the a tag, but I want the href that's inside the a tag. So I need to do brackets and then give it the value of my, or the name of my attribute within double quotes. That's one way to do it. Another way is to also do soup.a and then use the get method, which again is a method part of the soup object, and then in parentheses you pass it an argument by the name of your attribute, which in this case is href. Or there's another third way, which instead of using the get method, you can use the attributes or the attrs attribute of the tag name of the soup object, and then pass it in brackets the name of your attribute that you're trying to fetch. Okay, so there are different ways to do the same thing. I'm giving you the different options just so you can understand that, you know, what they are, and in case you see it down the line, you don't get confused or ask yourself, you know, why is it written this way? Well, it can be written this way, and again, over the years, code or syntax gets updated, gets improved, gets modified, and so these different ways are all applicable. Okay, so I'm going to run this code now, and let's review what we get back. Alright, let's start from the very top. Okay, so the first thing is the entire soup object. So this is the entire soup object, which is basically all the HTML that is behind my page. Okay, so all this HTML is exactly what we see down here. All right, it's the same exact thing. So we were able to fetch, again, using the request get method. I got back a response object, and from the response object, I passed the text value of the response object into my beautiful soup class, and I used an HTML parser to parse this data, and now it created a soup object for me. What is a soup object? Well, I printed it out here, and it, oops, sorry, and here is the output, which is exactly just the HTML that we saw in the page source. Okay, now then I applied what is called a prettify method on my soup object, and okay, so it's kind of here. So if I double click, all right, there we go. So this is the prettied up version of my soup object. Okay, now you might not notice much difference, but the difference really shows up here, starting from the body part. So notice how in the body the tags are kind of indented and they look nice and organized. So that means that the soup object got prettied up so that it looks nice on the eye and it's organized. But if I compare to the original raw soup object, you could see that everything is flushed to the left. All right. Now I know that things in the head are nicely indented, but the actual body HTML is flushed to the left. So that's the raw soup object. But if I apply the prettify method, then the body, as you can see here, has been not flushed to the left, but has been indented accordingly so that it looks nicer on the eye. Okay. All right. Then the next thing is we got the entire title tag from the soup object. Okay. And again, the title tag was up here. So that's exactly what we got. And if I look at the code, it's this guy here. So soup.title, when you printed it out, gave me this, which is what I expected. So soup.title is going to give you the entire HTML, including the opening and closing tags, as well as any text that's in between. Okay, but if you only wanted just the text that's between the two tags, the opening and the closing, then you would need to call the soup.title.text attribute. Okay, here is soup.title only, which gave you everything, opening and closing tags and text. But if you just wanted the text part, then it's soup.title.text, which would give you example.domain, which gave us just example.domain. And the next one was, let's get the text attribute of the title tag. No, sorry, that's what we did. Let's get the text attribute of the h1 tag, which is part of my soup object. And that's what we get here. Also example domain, because if you go back to your here's h1, here's the h1 tag, and the text in it is also example domain. So that looks like our code is working correctly. Then we have the a tag with everything in it. The opening tag, attributes, text, closing tag. And how did we get this? Well, we got this from this guy here. Okay, so soup.a is going to get us the a tag. Now you might wonder, what happened if I have more than one a tag? Well, this is only going to get the first one. All right, so if you wanted more, then there are different ways to do it. One way is to use the find method, but the find method is going to also only get you the very first instance of that tag that you're looking for. If you want to get everything, then you have to do a find all, which is another method under the soup object. Okay, so these first two do exactly the same. I'm going to get the entire a tag with the opening tag and the closing tag, the text in the middle, the attributes if any. But then this last one here, this one gives us just the text portion, which is whatever text is between the opening and closing tag. So that's why when we go to the results, these first two are the same, but then the last one only gives me the text of the a attribute, a tag. So the a tag has text, more information, ... and I was able to extract it using the soup.a.text syntax. Okay. Now again, you don't have to memorize this, because you can always go to the documentation. Okay. Everything is laid out here for you. Okay. There's no need to memorize it. But again, the first time you do it, you have to read documentation, and the more you get exposed to it, then you're going to start memorizing some stuff, and you could do it from, out of memory. To get the href tag, which is basically this value here. Okay. Now it's not going to include the word href. It's just going to include the value of the href attribute. Okay. And the way we did this is by saying support.a, and then in brackets you have to specify, well, what attribute do you want to get returned. And these are the three different ways you can do it. They all do the same exact thing. This is going to return this portion, as well as this is going to return this, and then this is also going to return this value. Okay, and let's confirm that, and here we go. All three return exactly just the href value. Okay, so that's just, getting our feet wet with working with Beautiful Soup. Let's look at another example. All right, so I told you that the find method, the soup.find method of any tag is going to get you the very first instance of it. But if there are multiple tags that you want to get all of them, then there is also the find_all method, and you pass an argument of the tag name. Okay, so here I'm fetching the rise.education. So actually, let's go there, copy, let's open up a new page. All right, so this page is the Rise Education website, and if I right click on it and go to show page source and go to the body, somewhere there. Okay, so you can see again this page has a lot of links. I just have to find them. A lot of A tags. Let's see. Okay, so here are some A tags and hrefs. These are links. Okay, some links are relative links. Some links are full-fledged absolute links with HTTP and so on. So there's a lot of, again, I know there's a lot of A tags in here, because once I find them and spit them out, okay, here's some more A tags. If we go back to our code, again, I'm basically doing the same thing, because I'm fetching data from the internet. I'm going to import the request library, and I'm going to also import the Beautiful Soup from BS4. Then I'm going to use the get method to pass it the actual website I want to go to, dump it into a response object, and then I'm going to call the Beautiful Soup class and give it the text that I want to parse, and then I'm going to tell it which parser I want to use, and then it's going to give me a soup object. So now I have a soup object, and then I want to loop through my soup object to find all instances of A tags. So the way to do this is I'm just going to do a regular for loop. I'm going to call the iterative variable links. So for links in, and then what am I looping in? Well, I'm going to be looping in whatever get comes back from the find all A in my soup object, which is going to be basically a list of href values. Okay, for every link that I find, I want to print it out. And again, we learned that I could use the get method from the iteration value and give it the href value, okay, of my soup object. So again, what this is going to do is going to loop through all the A tags. Again, you can change the A tag to whatever tag you're looking for, and just loop through one by one and then print them out, or do whatever you want to do with it. But for this example, again, I want to make it simple. I'm just going to loop through all the A tags, which are part of my soup object, and I'm just going to print them out one by one. So let's run this. And there we go. So now I can see that there are a lot of links or href attributes, which is part of the A tags, and some are full-fledged links, some are relative links, and so on. Okay, so this was just one way of fetching data, and then you get it back as an HTML text. We dump that into a Beautiful Soup, we parse it, and it creates a soup object for us. And once we have a soup object, then we could use all the different attributes, all the different functions or methods, and extract the data as we see fit. All right. Now, this example, or beautiful soup, is basically part of the first assignment. So if we go back to our week 5, basically we are covering web scraping and SQL. So web scraping basically is when you go out on the internet or on the web and you scrape the data. You're fetching data, you're getting data. But again, please make sure that anytime you want to go to a website and fetch data, make sure that you have permission to do so, or that it's allowed to do so. Because again, this is someone else's property, and you don't want to cause problems to yourself or cause problems to them as well. So that's technically what web scraping is. And our first assignment, assignment number 8, is basically asking us to go to a website. It's called the IMDb website. It's a movie database website. And well, if you click on this link here, it's going to open up this website. So this is the page that we need to go to. This is a page that shows the top 250 movies of all times based on users' ratings. Okay, so there are 250 movies here. What we want to do is we want to review all 250 movies, fetch all the actors of each movie, put them together in some sort of a dictionary, how many times they appear, and then once we have all that data, all the actors of all the 250 movies, how many times they appear, then we need to output a list of the top 10 actors who appeared in the most movies. So that's kind of the gist of the assignment. Again, it tells you all this right here. Okay, but I basically explained it to you already now. And so if you click on any movie, okay, let's say The Dark Knight, that's going to take you to another web page. And then if you scroll down just a little bit, you see stars here, and they give you 3 actors. Okay, so we need to loop through all 250 movies. For each movie, we need to see who the stars are, and then store those names in some sort of a dictionary, and then give the top 10 names of actors that appear in the most movies. So that's the gist of things. Okay, so we technically have to work with 2 pages. We have to work with this page for every single movie, and we also have to work with the main page to get all the movies. So first get all the movies, and then for every movie get all the actors of that movie one by one. All right. Now, whenever you work with data, whenever you go fetch data, you have to be aware of what this data is. Okay. So the best way to do it with HTML is to always look at the page source, just like I did with the example.com, just like I did with this one as well. All right. So with this document, you basically have to, again, right click, go to show page source, and we have to find, we have to study the HTML that's behind this. I know it's very ugly looking, but there are some easy ways to find it. Say I want to find, where the Shawshank Redemption is. And I could basically do this. Let's see, Shawshank Redemption. Okay, it's supposed to find it. Let's see if I do elements. And let's see, did I misspell it? Shawshank. Okay, so I get some returns. I'm trying to find where is... But basically I'm trying to find the HTML that is distinctive enough for me to find the name or the title of each movie. Okay, because I'm trying to get this value here. All right, now you basically have to do a lot of searching in the beginning. But for example, I clicked on this one and it showed me, okay, a link to the movie, and it has a class. Okay, now class is one way of finding something, and I think that's the one that I'll be using in my code. If you go through every single movie title, you're gonna find that it has a link, it has an href, well, it's an a tag, an href inside an a tag, and then it has a relative link to the movie page, and then it uses a class. So when we do the soup lookup or the find all on our soup object, we can specify to say, okay, find me all the hrefs in a class called ipc-title-link-wrapper. Okay, and that's gonna basically get me the link to go to the movie page. But we want to get the actual text as well. So here is the text here. Okay, now this might not be the very best text, so you always have to kind of it's a trial and error really when you're working with HTML. You try to find, okay, what is the best HTML tags that can help me find the data that I want. Okay, And so there's a lot of digging and a lot of searching in the beginning, and you have to keep trying, and if it works, great. If not, then you have to see, well, which of these classes, for example, or which of these tags would give me the data that I want. All right, so after some work, I came up with this. So this is the assignment. It's saying, again, fetch the 250 movies, go loop through them movie one by one, and then get the actors, and then tell me at the end what are the top 10 actors of these 250 movies. So my version of the solution is I'm going to import the request library, I'm going to import the Beautiful Soup library, and I have basically just one big function that does everything for me. And all the way at the bottom, I'm just going to call that function. Okay, so what does this function do? I have a URL defined. Again, that's from the assignment. It gave me the link. Now I'm using a header. Now the reason why I'm using a header is you're not familiar with using headers, I think, in the get method of the requests library. We're usually just used to request.get, and then we give it a URL, and that's it. But what I notice is after a few times, or even sometimes on the first try, when I try to do this, I get a 403 error. So a 403 error is that it's a client error where you're not allowed to access this website. Now the reason why is because some websites, they don't like you to basically web crawl on their website. Okay, they feel it's an invasion of privacy. They feel that maybe it could be a hack, or just someone trying to get data from their website that should not be there in the first place. So a workaround is to basically not just give it a URL value for the get method of your request object, but to pass it headers. And headers could be a lot of things. One of them is the user agent, which means the browser that you're using. So you can use exactly my header information. So in a communication or an HTTP communication standpoint, this whole thing here, this is basically me telling the request object, telling the server who should respond back that, hey, I am actually a person, I'm not a robot, I'm not a hacker, I'm a good guy, and this is my information. I'm coming from this type of browser, which is basically a Safari browser on a Macintosh. Okay, so when I do this, when I define my header, and again, you have to define it as a dictionary, the key is user-agent, and the value is all this. Now I didn't make this up. I basically searched it on the internet. I said, what's a typical user agent for a Safari browser, and it gave me this. So I just copied and pasted it into my code. All right. If you're using Edge, or if you're using an old IE version, or if you're using Chrome, just do an internet search on what is the user agent for this browser, and then just replace it with this value here. Or you can use mine exactly as is if you like. All right, because without it, your request might go through, but many times, sporadically, sometimes I get it, sometimes I get a 403 error, sometimes it works. So, just to save yourself some 403 errors, just add the headers. Again, that's the argument, and then set it equal to, I called it header because that's what my variable is called. But again, the argument is called headers, and you have to set it equal to some sort of a variable. In my case, it's called header as well. All right. Then I have an if statement. You don't have to have this, but again, it's just a way of, if I cannot connect to this website, in other words, if I get, we do know by now that 200 is a success status code. So if I don't get a status code of 200, that means something is not right. So I'm just going to print this statement and then return. All right, then I'm going to create a Beautiful Soup object from the response that I get back, and I'm going to parse it using HTML parser. Okay, and all that is going to be dumped into a soup object. All right, so far so good. So far nothing is really new here. What's new here is then I'm going to, from the soup object that I just created, I'm going to use a method called find_all. Okay, so because I know I'm not looking for just one movie, I'm looking for 250 movies. So I want to find all the A tags that have a class of IPC title link wrapper. So I guess I was looking at the right class. But notice here though that class is followed by an underscore. Now this is important because the word class in Python is a reserved keyword. Okay, so if I use class by itself, this is going to create an error, and the syntax wise it's going to yell at me. So Beautiful Soup said, okay, to make it as close as possible, we're just going to call it class followed by an underscore. What this is going to do is it's going to find, there we go, it's going to find this class here that is part of the A tag. So the find all is going to find all the A tags, not just all the A tags, but only the A tags that have a class of this value, which is this here, IPC title link wrapper. That is the name, right? Yep, that's the right name. So every movie, again, after me looking at the HTML and doing some searching and troubleshooting, I found that this is the unique way of finding titles and links of my 250 movies. All right, so I'm going to find all of them. Then I create and basically that's going to create a list for me, and I'm going to dump that into a variable called movie links. Then I define a new variable called base URL. Again, this is because notice here that this href is a relative link. Okay, it's /title / blah 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 blah. Okay, but I need the beginning part. I need the http://www.imdb.com. So I created a variable called base URL, which I will attach to whatever I get back for the movie link, which is the second part, which starts with /title. And I'm going to store that in base URL, which so together the base URL plus the movie link, that's going to give me the full path to the actual movie page, which, as we saw before, should take me to, okay, so see here, it took me to the movie page, all right, which has the stars, and that's where I'm trying to get to at the end. All right, let's go back. All right, now I know that I need to store the names of my actors as well as the how many times they appear in some sort of a data repository. So what better than a dictionary? Because a dictionary can have a key and a value. So I'm going to create a dictionary, and I'm going to call it actor count. Right now it's an empty dictionary, but that's going to help me to track my actor names and how many times they appear. So the key in my dictionary is going to be the actor name, and the value is going to be how many times they appear in movies. Okay, every time they appear, I'm going to increment their value by 1. If they appear again, I'm going to increment that value by another 1, and so on and so on. All right. Next, I'm going to now start to loop through my movie links, which is these guys here. Okay, so this soup find all A should return 250 movies. Okay, should return the links. Now, I did something different here that I don't want you to do at the end. I want you to do it at the beginning, where I'm looping through all the movie links, but I'm only looping through the first 11. Why the first 11? Well, because I noticed that if I run the 250, if I don't have this part, this is just a typical for loop, okay? I'm going to loop through everything in the movie links, which is 250 movie links. And again, it's rather slow. It takes maybe like 5 or 10 minutes to go through all the 250 movies and do everything that I need to do here. Okay, so just for you to run it in the beginning while you're troubleshooting and testing your code, just run it maybe for the first few movies. Okay, so I did, I said loop through the movie links, not 250, but only the first 11. Okay, the beginning is blank and it stops at 11. All right, so again, I only do this just for troubleshooting as well as investigating as well as demonstrating for you guys. I don't want you to wait 10 minutes for all the results to come back. But if it works for 11 movies, then it's going to work for 250 movies. Okay. All right, so now for every movie that I loop through, I need to get a movie URL, which is the full URL. And the full URL we said is going to be the base URL plus the link. From the movie links, I want to get the href value of it. If you remember from the page view source, every movie had a relative link. So the one that starts with a /title something something something. So to get the full movie URL, I'm going to append the base URL to the href value, which is the /title /something, which is part of the link, which is the iterator value of every movie link that I go through. Okay, So now that I have a full movie URL, then I want to fetch that using the requests object or the request library. So I'm gonna get that movie URL. Again, so I don't get the 403 error, I want to pass some headers, which are the same headers that I've used above. And that's going to create a new response object for me. Now I call it movie underscore response, so I don't confuse it with the other response object that I used at the top. So the top portion of this code got a response object for the main page that had 250 movies, and this response object is the one that's only specific to the individual movie. Okay, first response object is all 250 movies. This movie response object is just for the individual movies one by one. Okay, now again I have just this another status check code. If it's not 200, that means something failed, so I'm going to print a statement that something went wrong. All right, now that I have a new response object, I'm going to use it in my beautiful soup class. I'm going to get the text from that movie response object, which is the individual movie, and then I'm going to parse it using the HTML parser, and that's going to create for me a soup object. So this soup object, I named it movie underscore soup. Okay, so up here we had a soup object for the 250 movies. Here I'm in the for loop, which goes movie by movie. So this movie soup object is just for that individual movie. Okay, all right. Now here I just have a print statements, kind of like a debugger or just a status check that, okay, I'm processing, and then I'm going to give the full movie URL to make sure that am I in the right place or not. Okay, all right, so now that I'm in that movie, I need to find the actors. Now what I noticed also is that every movie lists 3 actors. Okay, but when I searched for the actual HTML that can help me find the actors, I realized that there is this HTML behind it. Okay, again, I don't want to walk you through the steps of searching and finding it, but just like I did initially with this guy here, okay, for the movies, the title and all, I was able to find this guy here when I was looking at the individual movie pages, and that's where they had the actors' names listed. Now I noticed that this, again, you have to find something that's very specific so you don't get wrong information. What I noticed is this value here, again, I'm not sure what the TT and OV stands for, but the ST stands for stars. Okay, so I'm trying to get the star names or the actor's name. I did notice that there are double TT underscore OV underscore ST for each actor. Okay, so that wasn't helpful. So my workaround is I said, okay, since they gave me 3 actors and then they gave me 3 actors again, the same 3 actors, I said, well, I'll create a limit variable set equal to 3. I'll create an index variable set equal to 0, and then I'm going to loop through each actor in my movie soup, and then I'm going to the select method of the soup object, you can pass, it's kind of like the find. You can pass exactly what you're looking for, which in this case this is my HTML that I want, and that basically is going to return the name of the actors. And here I'm just using the strip method in case there's any extra white spaces at the end. And to get the actual actor's name, I have to use the getText method of my iteration variable. Okay, and that's going to give me the actor name, and then I save it to a variable name called actor underscore name. Okay, now if actor underscore name that I just got up here, if this name appears in the actor count, what is actor count? Well, if you remember at the top, or almost at the top, there we go, this is my dictionary that I created. So I created a dictionary called actor count that's going to hold my actors. It's going to have the key value. The key is the actor name, and the value is how many times they appeared in the movie. Okay, so here I have a check. Now that I'm looping through the actor names, if this actor already appears in my dictionary, then I'm going to increment the value by 1. Okay, actor count is the dictionary name, actor name is the name of the key, and then I'm going to increment its value by 1. But if this actor name is not in actor count, is not in the dictionary, that means this is the first time they appear. So I'm going to go to the else statement, and I'm going to create the actor name the key, I'm going to set equal the value to 1. Okay, so if they do exist, then I'm going to increment the value by 1. If they don't exist, then I'm going to create a new key using the actor's name, and the value is going to be set to 1. Okay, and then I'm going to index the index value, which is set at 0, by 1. Now, why am I doing this? Well, because I want to loop through it only 3 times. I don't want to loop 6 times, because what I noticed is, again, this is, you find these things out by troubleshooting. There are 6 of these appearances. Every actor is listed twice, but I don't want them twice. I just want them once. So I said, okay, I'm going to limit my loop to just 3 times, and the index is going to be my counter. And every time I loop, I'm going to increment the loop by the counter by 1. But if the index is equal to limit, meaning that if my counter reaches limit, which is 3, then I'm going to break out of my loop. But if I'm still under 3, then I'm going to loop again, get the next value, check if he exists in dictionary or not, and then act accordingly. And also, if for whatever reason there are no actors in this list, most probably because maybe my href is not correct, or my HTML is not correct, then I'm going to go to the else statement and then say actors list is not found for this movie. All right. Now, once I'm done looping through all my actors and dumping them into my dictionary, then I have to decide, well, I want to get my top 10 actors that appeared in the movies. So I'm going to create a new variable called top actors, and I'm going to use the sorted method, which is a built-in Python function, and it takes a few arguments. It's going to say, okay, what do you want to sort? Well, I want to sort my actor count, which is the dictionary, and the items in my actor count. Items are basically the key and the value. So I want to sort my actors and their values and how many times they appeared. But I also want to specify how I want the sorting to be. So I'm going to create a lambda function, which we learned about in the first class, last session, last semester. And basically the key of how you want to sort is basically the lambda function of x, and now x is which argument do you want to sort by, the key or by the value? Well, x is my variable, and I'm using x index 1, and indexes are 0 based, so x0 is basically the key and x1 is the value. So I want to sort by the value, and the value holds the number of count these actors appeared. But I also want to reverse the order, because I want to get the actors in descending order. So if someone appeared 10 times, go first, and then if someone appeared 9 times, they go next, and so on. So it's descending order. Okay, and I want to do this for the first 10 actors in my list. Okay, not all of them, just the first 10. Now I have sorted the first top 10 actors in descending order, and I assign the result into a variable called top actors. And once I have top actors, then I'm going to do a print statement that says top 10 actors with the most top 250 movie appearances, and then I'm going to loop through them, again the key and the value in my top actors variable here, and then I'm going to print the actor's name, followed by the number count, followed by the word movies. All right, that's basically for this assignment. So if I run this now again, I'm only going to return the first 11 movies, just so it doesn't take a long time. So I'm going to run it. All right, so you can see now that it's printing out the processing movie print statements, and this is the full URL for the different movies, and again it's going movie by movie. So I have movie 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there we go. So it got the first 11 movies, and then here's the print statement, the top 10 actors with the top 250 movie appearances. It seems that Al Pacino has appeared in 2 movies. It's a tie with Elijah Wood, Ian McKellen, and so on and so on and so on. All right, so it seems that the code ran correctly without any errors, but again, it took a while to get there. So again, you can certainly use my code. Again, the whole point is that you play around with it, you learn from it, and of course make some mistakes and stumble, and that's how learning happens, and that's how growth in programming happens. Okay, So that was the first assignment, which was to fetch the top 250 movies from the IMDb website using the request library and using Beautiful Soup. If you have any questions or you're confused about something, please reach out to me at any time. All right, let's move on now to the second part, which is SQL stuff. Now let's talk about SQL. So SQL stands for Structured Query Language, and it is a powerful language used to access and manipulate databases. So let's break down what SQL is and why it's so essential in the world of data management. Basically, SQL serves as the common language for interacting with databases. It provides a standardized method for communicating with various database management systems, regardless of the underlying architecture. So whether you're working with an Oracle database or MySQL or SQL Server or any other relational database system, SQL offers a consistent syntax and functionality. And this uniformity basically makes it easier for developers as well as analysts and database administrators to work across different platforms seamlessly. You see, with SQL, you can retrieve specific data from databases using select statements. You can filter results with where clause, and you can perform complex calculations and aggregations. SQL also allows you to modify data with insert, update, and delete statements, which helps to ensure the integrity and consistency of your database. And of course, SQL also empowers users to analyze and transform data efficiently, making it a cornerstone in data analysis, as well as reporting and business intelligence. So in short, SQL serves as the backbone of modern data management, and it offers a standardized language for accessing and manipulating databases with ease. Now, SQL allows us to work with both databases as well as tables that are inside these databases. So the database is the big container, and inside the database we can hold many tables. And so SQL provides commands to create, alter, and drop databases as well as tables. For example, to create a new database, we use the create database command. To alter or change an existing database, we use the alter database command. And to drop a database, we use the drop database command. Now let's move on to table management. SQL also allows us to create, alter, and drop tables within a database. So to create a new table, we use the create table command. To alter an existing table, we use the alter table command. And to drop a table, we use the drop table command. So as you can see, these commands are used to work with databases and tables. Now let's explore CRUD. These are operations which allow us to work with records or the actual data inside our tables. And CRUD stands for create, read, update, and delete. These operations are fundamental to working with records or data in our tables, which are part of our database. So the hierarchy of things goes as follows. We have a database, and inside the database we have tables, and then inside the tables we have data, which are also referred to as records. Now, to create or add records in a table, we use the insert into command, and then the word table will be replaced with the actual name of the table. And to read records from a table, we use the select statement, and here I have select star from table. Now the star or the asterisk character means to return all records and all columns in the table. So basically return everything. Now to update records in a table, we use the update command. And this command gets a bit more complex as we need to specify which records we need to update, so we can use the where clause. And I'll show you some examples soon. And to delete records from a table, we use the delete command. Now, one thing I always caution people about when using the delete command is to double check your syntax before you run it, because it will wipe out data based on your command. So please be careful. And the same thing goes for the update command. I mean, even with the update command, if you write it incorrectly, it can change data that you didn't want to be changed in the first place. So again, please be careful when creating SQL statements that will alter your data. Alright, so let's start working with these commands to become more familiar with them. But first, I need some sort of a platform, an environment, or a database management system to work with databases as well as tables and data. And for that, I will go to DB Browser for SQLite. this is a robust tool to allow us to work with SQL databases. Now, you don't have to use this particular tool, but it's simple to use and very lightweight with a gentle learning curve. So I suggest you download it and install it for this week's assignment. I also suggest looking around in the docs page, as it has a plethora of helpful information. In general, you should always be spending time in documentation to learn something new or to look up how to do something. So to access the page, you can basically go to sqlitebrowser.org, or you can also do a search online for SQLite browser or DB browser for SQLite. And this is the main page, has some information on it, okay, even previous versions. But the main site or the main page I want you to go to is the docs page, because the documentation page basically tells you, how to use it and all the functions and properties of how to use this tool. Okay, so I'm going to open up a database that I've created from before. So this is the interface for DB browser for SQLite. So once you have it installed and downloaded and installed, open it up, and you basically can create a new database. You can open up an existing database. You can close the database that you're working with. And then in the middle here, you have 4 tabs. Database structure is going to give you what your tables are. And right now I have 1 table. And if I expand it, I can see that table is called customers. And if I expand it more, I see that it has 4 columns. There's an ID column, which is an integer type. First name column, text-based, last name column, text also, and age is an integer. Okay, so I already created this. Again, I'm going to show you some examples, so I just didn't want to waste your time by creating something and having you watch me. So I created this database, but this is a database that has 1 table, and I can go to the Browse Data tab, and up here, if you have multiple tables, you can click on the pull down arrow and you can choose which table you want to view. But right now I'm viewing the customers table, and I have ID column, first name, last name, age, and just to have some random data that I made up. Okay, you don't need to worry about the edit pragmas, but then execute SQL is where we're going to be spending most of our time. Alright, so to play with SQL code, you basically, like I said in the presentation, you have to use some SQL commands. The simple one is select. Select is basically going to fetch data and display it for us. And the select is the command to fetch data. I'm going to do select star so I can get everything. So select star from, that's a keyword, from, and then you have to follow by the table name. In my case, it's called customers. Okay. And now to run this code, you can multiple ways to do it. You can click on the play button or the run button here. That's going to run it for us. Or you can do, if you're on a Mac, it's Command R. If you're on a Windows, it's Control R. Okay. Or you can also do F5, as you can see here. So I'm going to click on the run button, and the select star from customers displays. These are the results. And then this is the information of what my command did. Okay, so it executed, finished without errors. That's a good thing. Returned 9 rows in 11 milliseconds. At line 1, I just have 1 line, which is select star from customers. Okay, so select star from customers is the very basic select statement. Now, say you don't want to get all the data, or say you don't want to get all the columns. Okay, say you just want the first name. So instead of saying select star, I can say select followed by the column name, which would be first underscore name. Okay, then I'm going to run this. I only get I get all the records, but only the first name column. All right, if you want to get multiple columns, you could also do first name, age, and then play, and you only get first name and age. Okay, let's go back to star again. Let's say you want to get everything, but not all the records, but only where. Where is the where clause. It's a reserved word. Where, let's see, age is equal to 22. Okay, so I only want to get the records in customers where age is 22. So in this case, there is this one, and then there is Jen. So there is, I think, Mel and Jen, both are 22 years old. So if I run this, I only get the records that meet this search criteria. Okay. You can also create multiple lookups in your where clause. So here I have where age equals 22, but then I can also say and, let's see, last name is equal to Logan. Okay. Now notice here, 22 is an integer, so I don't have to surround it by quotes. But Logan is a text or a string, so I do have to surround the value by double quotes. So what this is saying is, says select star from customers where age is equal to 22 and last name is equal to Logan. So I want both of them, both these criteria, to to fit and return these results. So I'm going to run this, and I only get one now. Okay, the age is 22, that fits. The last name is Logan, so that's the only record that matches this where clause. Okay, I can also order. I can also sort. There we go. I can also sort my data. So if I do select star from customers and run it, I get everything back. Okay, but say I want to sort my data by age. So I can say order by, that's another reserved word in SQL. So order by, then you have to say which column you want to order by. I'm going to order by age. And if I run this, let's see what happens. So it ordered by age, and it ordered it incrementally. Okay, now if you want it to be reversed, meaning oldest to youngest, then I'm just going to follow by the keyword DSC, which is descending. Okay, so select star, so give me all the columns on all the data from customers, but order them by the age column in descending order. So when I run this, now I get all my data, but I order them by age and descending order, as you can see here. Okay, you can also get the count of something. So if you want to look up how many records are in your data, in your table, I'm sorry, you can basically call the count method, which is a SQL method, and there are a lot of SQL methods you can look at, and then as an argument pass it everything. So say, give me the count of everything in the customers table. So if I run this, I'm just going to get a value of 9. Okay, so there are 9 records in my table. Okay, so that's just some basic manipulation of SQL statements. Now let's go to the assignment. So our second assignment basically is the one for SQL, and please read this part here. But basically it says that we have to install a SQL environment to work with SQLite, and again in this case I've mentioned that you should work with the DB browser for SQLite. Again, you don't have to, but it's an option. And then we have to create a SQL script called world_cities.sql. So SQL syntax, when you save it to a file, it should be in a .sql extension. We need to write a SQL statement to create a table named cities, and this should have the following columns: an ID column, a name column, population, and country. And then also the ID needs to be a unique identifier, meaning that it's a primary key. So in SQL statements or SQL tables, there's something called a primary key and a foreign key. Primary keys are basically, it's a column where the values or the data in it cannot be repeated. They're unique. Okay, and how this helps us is that we can identify, or we can pull up these records by that primary key as an identifier. So for example, some people might use just 1, 2, 3, 4, 5, 6 as IDs. Some people might use GUIDs, which are globally unique identifiers. Some use social security numbers, which is not the best way to do it. It's poor database design to use social security as your unique identifier, just for privacy and security reasons. But it is a unique number. So the point is that primary keys are unique identifiers for the data in your table. Okay, so the ID column needs to be a unique identifier for each city. Name is the name of the city, population is the population of the city, country is the country where the city is located. Then we need to add data to the cities table, and it says that this data can be real or made up, but have at least 10 different cities from at least 5 different countries. Be sure to include a mix of small and large cities. And then we need to write SQL statements to perform the following tasks. We need to select all our cities in our table. So this is the select star from table. And then select all cities in a specific country. Again, this is the where clause. And then we have to update population of specific city, which we haven't seen yet, but I'll show you. And then we have to delete a specific city from a table. Again, we haven't seen yet, but I'll show you in a moment. Once you've tested this and it works, again, in whichever DB tool you want to be using, save your SQL file and then upload it to your assignment. So I'm going to go back to the DB browser. I'm going to close this database. I'm going to create a new database. Actually, I can close this tab also because I don't need it for now. I don't want to save anything. I'm going to create a new database. Okay, I'm going to put it here. Let's call it class 1. I'm going to save it. I'm not going to create the tables here because the assignment says to create a SQL syntax or SQL commands to create a table, to populate the table, and to run some queries on it. So I'm going to cancel out of this. And for my SQL command, I can open up my file that I already have. Open SQL file. This is the icon. Click on that. Okay, so this is the SQL file that I created for this assignment. I don't have the create database command turned on. Basically, the double dashes is a way to comment out your code. Okay, so this is in green, means that it's comment, so it will not be executed. My first command is create table, followed by the name of the table, which is cities, and then in parentheses I'm going to include the column name and then any attributes. In this case, it's a primary key. And then next column is name, followed by the type, which is text, followed by the column name, which is integer, followed by the column name, which is text. Okay, now I have a semicolon here just because I noticed that within DB browser, if you have multiple lines that you want to run at once, then you have to separate them by semicolons. If you don't, it's going to yell at you. Okay, now I can run this entire file by clicking on the run button, or I can just put my mouse here, and then this icon here says to execute current line. Okay, so if I do that, then I'm going to execute it line by line if you want to. But I'm going to explain all the lines, and I'm going to run them all together. And you can see here that if I click on, first of all, the database structure, I don't have any tables yet. Okay, and also browse data. Well, there's nothing to browse because there are no data yet. Okay, so here I'm going to create my table, then I'm going to insert data into it, and then I'm going to do some select statements on it. Okay, actually let me comment the delete statement because I don't want to delete it yet, and let's comment this because I don't want to update it yet. Okay, alright, so this is my create statement. I'm going to create a table called cities, and these are the 4 columns. Once I have that table created, then I'm going to insert into cities. So now I have cities created, so now I can insert data into it. And the syntax is insert into table name, and then in parentheses give it the columns, which is name, population, country, and then followed by the word values. And then the values are going to be, for each record, going to be 3 things. I'm going to give it the name of my city, which is name. I'm going to give it a number for my population, and I'm going to give it a name for my country. Okay, so this is one record, followed by a comma, followed by another record, followed by a comma, and so on, all the way until I have, I think, 10 cities with their population and country names. Okay, so that's, once I create my city table, I'm going to dump data into it, and once I have data dumped into it, then I'm going to start doing some select statements and see what I get back. The first select statement is just the select star from the city, so I'm going to get everything back, and then I'm going to, well, here, let's also comment this one out so I don't confuse the results. Okay, so that's all I'm going to be doing. I have a database created called class 1. I'm going to create a table in that database called cities. I'm going to populate the cities table with some data, and then I'm going to do a select star from cities. So let's run this, see what happens. Alright, so I got data back, which is good, but let's check first of all the database structure. Okay, now I have tables as 1, and it's called cities, and if you expand it, you have ID, and you can see that it has a primary key icon next to it. I know it's small, but it's that yellow thing here. And then it has name, population, and country. So it looks like it was set up correctly. And if you click on browse data, now I see my table cities is there. It's the only table. And then I have the table correctly populated in the table here. And then in the execute SQL, because of this select star from cities, I got my table data back correctly. And this information is indicative that I had no errors, which is a good thing. Alright. The next select statement that I want to run is this guy here. Now, since I only want to run this line, I don't want to run the previous lines because I already have run them. I'm going to click on this anywhere in this line, and then I'm going to click on this icon here that says only run this line. Okay. Another way to do it also is to just highlight the line that you want to execute and then click on the run button. But what this is going to do is it's going to select star from cities where country is equal to United States. So here I have United States, and that's the only record that has United States. So I should get back just one record when I run this. So if I click on run with this line highlighted, I just get back that. Okay. Now again, if you want to run this line without highlighting it and only this line alone, then click on this icon here that says execute current line. So I run this and I get all the data back. All right. Now let's come to the update statement. So the update statement, I'm going to uncomment it out, basically allows us to update data that's in our table. So the syntax is use the update keyword followed by the table name followed by the set keyword followed by whatever you want to update. So I want to set my population to all these ones. That's the value that I want to set my population value to. But which record? Well, that's where the where clause comes in, where the name is equal to Mumbai. So name, here is Mumbai. It's this record. Right now the population is this number here. I want to update this population to be a bunch of ones. Okay. And if everything is correct, then when I run this, let's run this command here, this line only. So it ran without errors. And now let's browse our data. And there we go. Mumbai now has population of all ones. So this looks like it ran successfully. Okay. The next thing we want to test is the delete statement. Now again, with update and delete, you always have to be careful that you are sure what the command is going to be doing, because there's no backtracking. Once you delete or you update, then the data is there. You can go back and re-update it again, but again, just be careful with update and delete. So I'm going to uncomment the delete line, and basically this says delete from cities. So I'm going to delete from cities. Now if I stop here, if I have this commented out, if I say delete from cities, then it's going to delete the entire table. Okay, not the table itself. It's going to delete the records in the table. So be careful. So I'm going to remove the double quotes, the double dashes. So I don't want to delete the entire records. I want to delete only where the name is equal to Paris. So if you browse your data, I have Paris somewhere here. So here's Paris with this population and this country name, which is correct. I want to delete this record. All right. So delete from cities only where the name is equal to Paris. So I'm going to click here anywhere on this line. Then I'm going to run this current line, and I get execution finished without errors, which is good. Let's double check, and I no longer see Paris. So that works. Okay, so now that you've tested all these commands in your whichever database tool you want to use, and you verified that they work correctly, then please save that file. For here, you basically go to, let's see which one is save, open, save. There you go. So you click on this icon to save your SQL file, and then submit that into the assignment area. Okay, so that was it for this week. Again, it's a lot of information. If you have any questions, please let me know. I'll be more than happy to help out. Thank you for watching. I'll be seeing you in class. Take care, and bye for now.